Question 5. Given that y equals 3 sine theta, all divided by 2 sine theta plus 2 cos theta, in the range theta is from negative pi over 4 to 3 pi over 4, show that dy by d theta is equal to a over 1 plus sine 2 theta in the same range for our theta, where a is a rational constant to be found. So we've got a function where we've got a function divided by another function, so that implies to us we're going to use the quotient rule. We've also, the thing that we're going to try and get to has a sine 2 theta in it, so we need to remind ourselves about trig identities. So first of all, the quotient rule. So if we differentiate two functions, so u and v, where one is divided by the other, the quotient rule tells us it's v times the derivative of u, subtract u times the derivative of v, all divided by v squared. I also know that sine 2 theta, so using our double angles, so there's only one option here, is 2 sine theta cos theta. So these are the things that are probably going to be necessary here. So when I'm using the quotient rule, what I like to do is just label what my numerator, my u, and my denominator v are. So u will be 3 sine theta, and v will be 2 sine theta plus 2 cos theta. So u dash, to differentiate 3 sine theta, you get 3 cos theta, and v dash, so you get 2 cos theta, and 2 cos theta differentiates to negative 2 sine theta. So now I can put these all in the formula. So dy by d theta is going to be equal to v multiplied by u dash, so those two, so open bracket 2 sine theta plus 2 cos theta multiplied by 3 cos theta. Subtract u v dash, so those two times together, all divided by v squared. So we'll do a big division, 2 sine theta plus 2 cos theta squared. And so we're just going to need to do some simplification here. So let's start multiplying out our brackets. So dy by d theta is going to be equal to 6 sine theta cos theta plus 6 cos squared theta. Subtract 6 sine theta cos theta, so that's nice, plus 6 sine squared theta. And then your denominator, so we just need to be careful on the bottom here. So we've got this bracket squared. So remember that if you had a plus b squared, that's a plus b multiplied by a plus b. So you've got to be careful multiplying out. So you get a squared plus ab, so plus 2ab plus b squared. So that's the idea we need to apply here. So 2 sine theta times 2 sine theta is 4 sine squared theta. 2 sine theta times 2 cos theta will be 4 sine theta cos theta, but you're going to get that twice. So it's going to be plus 8 sine theta cos theta. And then 2 cos theta multiplied by 2 cos theta is going to be plus 4 cos squared theta. So some things cancel out nicely here. So you've got 6 sine theta cos theta, subtract 6 sine theta cos theta, so that will cancel out. And then what we need to notice is also we can use our trig identities. So 6 cos squared theta plus 6 sine squared theta is just going to be 6. 4 sine squared theta plus 4 cos squared theta is going to be 4. Now if we look at our identity, sine 2 theta is 2 sine theta cos theta. If you multiplied here everything by 4, so if you'd have 4 sine 2 theta, that would be equal to 8 sine theta cos theta. So actually, we've got 4 plus 4 sine 2 theta on the bottom. Now, if we look to what it was trying to get us to show, we've got a 1 plus sine 2 theta on the bottom. So if we divide everything by 4, top and bottom, so 6 divided by 4 is 1.5, or 3 over 2. And this gets us 1 plus sine 2 theta on our denominator. So this implies then that a must be equal to 1.5.